logarithmic functions. So in the past, we have been learning about exponents. So like, for example, we know that 2 to the second is 4, 2 to the third is 8, but what value of x does 2 to the x power equal 6? Well, we can figure this out by using a logarithm, which can be written just like this. So our logarithmic form, log base b of y equals x. So we have three main components to take a look at. We have our base, we have our of value, which is y, and then we have our x on the other side. So the first thing we're going to look at is fill in the missing form of a logarithm or an exponent. So when you're going from a logarithm to an exponent, I like to think of this as the Amazon logo, where you take your base and your base becomes the base of your exponent on the other side. Okay? I think of it as the Amazon logo because it looks like that arrow smiley face, but other people call it the wheel method as well. So we could rewrite this as 2 to the third power equals 8. Okay? So that's how you go from a logarithm to an exponent. And the other way around, we are going to take our base of our exponent, and that's going to become our base of our logarithm on the other side. So in this case, I have log base 12 of 144 equals my exponent, which is 2. So that's how you go from an exponent to a logarithm. Okay, let's do a couple of these examples. So same thing here, use the wheel method or the Amazon logo. So if I wanted to rewrite this as an exponential, I have 81 equals 3 to the fourth power. Okay, I can do the same with these other ones. Number 2, once again, I have 7 equals 7 to the first power, which obviously we know that is a true statement. And I'll save the other ones for class. Okay, next we're going to evaluate a logarithm. So whenever you evaluate a logarithm, you are going to want to set it equal to x. So I have log base 4 of 64 equals x. So we're going to figure out what this logarithm equals. So in order to figure out what it equals, the first thing I would do is I'd rewrite it as an exponential. So I could rewrite this as 64 equals 4 to the x power. Now, I think the easiest way is to ask yourself 4 to what power is 64? And if it works out nicely, you'll be able to figure this out. So let's see. Down here we can list them. 4 to the first equals 4. 4 to the second power equals 16. 4 to the third equals 64. So that means that in order for my equation here to be equal, I need to have 4 to the third power. So that tells me that x has to equal 3. All right, we can also do those with fractions. So same rules apply. Rewrite it as, set it equal to x. Then let's rewrite it as an exponential. So I've got 1/25 equals 5 to the x power. So remember, in order for us to go from a whole number to a fraction with an exponent, we are going to need negative exponents. So once again, we can write these out. 5 to the negative first, which equals 1/5. 5 to the negative second equals 1/25. So in order for my equation to be true, I would need to have x equal to -2. All right, so that's just a quick start on evaluating logarithms. Okay, there's even more examples on the backside here. We'll save a couple of them for class. So there are cases where there are like two special logarithms that we look at. So the first one is a common logarithm. So that's a logarithm where they do not list the base. So if they do not list the base of a logarithm, we just call it a log, and that just implies that it has a base of 10. So as you guys can see down here, both log base 10 of x and log of x are equal. They both have a base of 10. Your calculator can actually calculate common logs. Another type of logs that can be calculated in your calculator is a natural log. So a natural log has a base of e, which is implied. And we can just rewrite that as ln for natural log. So let's look at evaluating a couple of these. So we are going to evaluate them using a calculator, and we're going to round to the thousandths place. So for the first one here, I have the common log of 100. So I know that this means the same as log base 10 of 100. It's interchangeable. So I could calculate this out, but like it said, we can also use our calculator, use the log key. See, I suppose I can pull mine up. Maybe. Oh, 1 second here. And maybe it doesn't want to load. Oh, it's right there. Oh, there we go. Perfect. All right, so to evaluate your logs, see if I can get this giant thing out of my screen. There we go. Okay, sorry about that. So to evaluate your logs, you are going to use the log key. So I would press this log key right here. It's right above natural log. It implies a base of 10. Type in 100, and it's going to give our answer, which is 2. Okay, we can also do this with natural logs. Once again, I could rewrite this as log base e of 33. This isn't necessary though, because your calculator will do it for you. So in this case, we'll press the natural log button, 33, press enter, and that's going to give us 3.497. Okay, so those are the two types of logs you can evaluate in a calculator. All right, so if you have a exponent in your log, then you can cancel out both your base and the exponent. So if I wanted to, I could cancel these out, and that's just going to leave me with my solution, which is 3. In a case like number 3, we could rewrite 16 as an exponent with a base of 4. So I could rewrite number 3 as log base 4 of 4 to the second power, because 4 to the second power is the same thing as saying 16. At this point, both your exponent and your base will cancel, leaving me with my solution, which is 2. All right. It also works kind of the other way, where you have an exponent, a base of an exponent, taken to the exponent of a log. So remember, this log has an implied 10. So since the base of my exponent and the base of my log are the same, these are going to cancel as well, leaving me with my solution, which is just 4. All right. So the next section is finding inverse functions. So remember, when finding an inverse function, if it's written as f of x, we're going to change it to y. Then we're going to switch both our x and y values. Once we've done that, our goal is to isolate the log or the exponent. Then we'll switch the forms so that we can finally solve for y. So let's do number 1 as our first example here. So in number 1 here, the first thing we're going to want to do is switch our x and y. So I could rewrite this as x equals 6 to the y power. Now, since I'm in exponent form, my exponent is isolated, right? I have 6y all by itself. But now, since I'm working in exponent form, I'm going to want to rewrite this as a log. So, since I have an exponent of 6 and I'm trying to cancel out my exponent, I'm going to use a log base 6 and do that on both sides. So, on my left side, I've got log base 6 of x. And on my right side, I have log base 6 of 6 to the y power. I use this log because then ultimately, on my right side, it's going to cancel out, leaving me with y. And on my left side here, there's really nothing I can do. So I'm left with log base 6 of x equals y, which would be my final solution. All right, taking a look at number 2 here. Number 2 is another one of our special logarithms because we have the natural log. So remember, in order to cancel out the natural log, we need to have e, because I could rewrite the natural log here as log base e of x plus 3. So in order to cancel this out, I'm going to have to use e as the base of my exponent. So that's going to be my first step. I'm going to take everything to the base of e. So I have I'm skipping ahead here. I forgot, we need to switch our x and y. So I have x equals the natural log, and I'm going to rewrite it as, actually no, I'll leave it as a natural log. Natural log of y plus 3. So my first step, swap my x and y. Now I'm going to take everything to the exponent of e. So I've got e to the x equals e to the natural log of y plus 3 power. Okay, once I do this, since my natural log has a base of e, these are going to cancel out, leaving me with e to the x equals y plus 3. Now, this is super simple. If I want to solve for y, I'm just going to subtract 3 from both sides, leaving me with e to the x minus 3 equals y, which is my inverse. All right, so that should give you just a quick introduction on finding inverse functions. This process is a little bit difficult to get started, but with some practice, we'll get there. All right, scrolling down here. Let's work on simplifying some of these expressions. This is exactly what we were doing on the last page. So once again, your exponent and your base will cancel out, leaving me with just x. And same goes here. My base and my base of my exponent cancel, leaving me with just negative 3x. All right, so let's find the inverse of one more of these. I think it would be helpful to do number 5. So the first step on number 5 is let's swap our x and y. So I can rewrite this as x equals 4 to the y minus 3 power. So right now I'm in exponential form, so I'm going to want to switch this to a log. So since I have my exponent has a base of 4, I'm going to use log base 4 equals log base 4 of 4 to the y minus 3 power. Once I'm here, both of my bases are going to cancel, leaving me with log base 4 of x equals y minus 3. All right, once I'm here, I can solve for y by simply just adding 3 to both sides. And that's going to leave me with log base 4 of x plus 3 equals y. So that's just another quick example of finding the inverse. All right, I know this lesson's getting pretty long, but it'll probably be covered in 2 days of class. So the last part of this lesson is graphing a logarithm. So the first thing you want to do when graphing a logarithm is I typically convert this to exponential form by using the wheel method or the Amazon method. Then create your table by placing values on your y side of the chart, because that's going to be the y-axis will be your asymptote. So let's just do a couple of these. Let's do number 1. So first, let's rewrite this as an exponential. Remember, we'll use the wheel method here. So I can rewrite this as 3 to the y power equals x. So since x is our isolated term, that's why we are going to choose our y values, and then we will substitute those into the equation. And actually for this one, I'm going to go all the way to 2. So it's really easy to substitute these. We have 3 to the negative first power, which is 1/3. 3 to the 0 power, which is 1. 3 to the first power, which is 3. And 3 to the second power, which is 9. Then we can go ahead and graph these. At my y value of negative 1, I've got 1/3. At y value of 0, I have 1, 1 and 3, 2, and 9. So my function is going to look something like this. Where remember, the y-axis is our asymptote, so it'll get really close to that, but it'll never actually touch it. Okay, let's scroll down and do number 3 here, and then we'll call it. So for number 3, I am going to do both 2 and 3 as well, because those will fit on the graph. So first things first, let's rewrite this as an exponential. So I'm going to use the wheel method. So I've got 2 to the y power equals x plus 3 plus 1. Sorry, I should have done one thing first. Let's take it back a step. So before you can use the wheel method, you do need to isolate your logarithm. So I should have subtracted 1 first. So really, I've got y minus 1 equals log base 2 of x plus 3. I totally forgot about that. Now I'm going to use the wheel method with my 2 value. So that gives me 2 to the y minus 1 power equals x plus 3. I want to isolate my x value, so I will subtract 3 over. So that's going to give me 2 to the y minus 1 minus 3 equals x. So that's the function that I'm going to be graphing right there. So when substituting in a negative 1, that's going to give me 2 to the negative second power, which is 1/4, minus 3, which is negative 2 and 3/4. 2 to the negative first power is 1/2, minus 3, gives me negative 2 and 1/2. 2 to the 0 power is 1, minus 3, which is negative 2. 2 to the first power is 2, minus 3, which is negative 1. And 2 to the second power is 4, minus 3 is just 1. So I know I went through this kind of quick, trying to keep the video as short as possible. So I've got negative 1 and negative 2 and 3/4. 0, negative 2.5. 1 and negative 2. 2 and negative 1. 3 and positive 1. So I will have a graph that looks something like this. So the only thing to pay attention to here is I do have an h value of positive 3. So that's what causes my asymptote to go from the y-axis to negative 3 in this function. Remember, it's the opposite of the sign. So I know this video got super long. Thank you guys for sticking with me. Please ask any questions you have in class. Like I said, we are most likely going to break this lesson into multiple class periods, but let's take the initial notes all in one. All right, thanks for watching.